So, today I'm going to talk about software architecture and the patterns. A pretty loud name for the title for presentation, right? So the thing is that I work with different software development companies, product companies, and I decided to collect a bunch of problems that are shared between them, like same problems all the same time and the same rakes. So, and I will start with the first one, and a pattern that I call Lasagna Architecture. Basically, you ain't gonna need it architecture, or in Russian, nafiga architecture, right? So, nafiga. Funny, yeah? So, Lasagna Architecture, basically, we're all like a buzzword-driven people, right? We're like have this very special kind of technological fetish, right? As a software developer, right? Like we have a fetish on the technology. Let's say we want our applications to be reactive, right? Nowadays, reactive is the way to go. Let's go reactive, right? So we want to be reactive. Okay, we want our applications to run on, let's say, Cassandra or MongoDB because MySQL is boring. Even if you have single JSON document to store, right? Who cares? Anyway, we want like a document storage to use, or we want microservice architecture, right? Because everyone is talking about microservice architecture now, even if no one doesn't really need that. So anyway, we want to be fashionable. And there's a reason for that. Because first of all, how we find a job normally. There's a headhunters on LinkedIn that look for developers using some keywords, like a big data, something. And that's a good reason, right? We have to be like a modern and fashionable at least, because otherwise we'll stay without a job, right? That's how people hunt us usually, for this fancy buzzword. And actually, you're lucky enough if your company admits that kind of using these fancy technologies is the way to go and accept something that's called marketecture, right? Like architecture in the sake of marketing and all this stuff. Otherwise, you hit the wall and you don't really get like a acceptance for doing some fancy stuff. And I want to tell you a short story, and you judge whether it's funny or it's sad. The thing is that once my friend produced a tweet. He said, how to get a business blessing to break a monolithic system into microservices. Kind of pretty good question, right? And I replied, hey, is it really a service or a microservice architecture, maybe a lack of microservice architecture that slows you down? Maybe you have to find the constraining factor. Maybe it's a service that tries to escape from your system. Maybe there's a constraint or something that slows you down. And it makes him extremely sad. He said, what the fuck? He said, what the fuck, Edward? Why are you asking these questions? What the fuck? Microservices is the way to go. I said, just slow down. Hey, everything's okay, man? No, Eddie, you don't get microservice architecture. And he actually won the battle. He won the battle. He sold microservice architecture to business. He collected the team, came up with some fancy ideas or bonuses of microservice architecture and sold it to management and won like a year of time to build this microservice architecture. After a year, he left. He just left the company. He left just before company realized that they spend the money on something that they don't really need. Just a year of work doing something that no one actually needs. And he left, and right now he's probably selling new fancy things to another company, right? That's how it is. I'm not going to blame him. However, it's sad, right? Where's this professional ethics that we should have? Where is that? And the message is very simple. I believe that some software actually is never intended to stay out of the crowd. And chances are that right now you work on this kind of software. Maybe your software will never be fancy. Maybe your software will never be cool because maybe it's some boring enterprise or something and there's no place for fancy stuff. Just admit it. That's harsh, right? That's harsh. But we want to play with some cool stuff. And you work now on something boring. Wow. That's sad. And I have two solutions for you. The first one, just quit. Seriously. Just quit. I don't think that it's better to lie to someone or find like a unreasonable explanation for something that shouldn't really be done at all. So it's about professional ethic. You have to be fair and honest. And don't spend someone's money, because most probably it's not your money actually at all. Very harsh. Now it's even more harsh, right? However, there's an alternative. The thing is that maybe in your particular company, there's some place for business innovation. I believe that business innovation starts first, and then technical innovation follows, not vice versa. I have a real-world example, basically. I've been working with a software development team, and they've been working on a product. And the thing is that they had problems with data analysis. They had a lot of data, and like a decision-making took them a day. And they needed this decision-making agility. Team decided to produce a quick prototype and show it to business. In their spare time, actually, they did this like a brown bag session, did some R&D stuff, and produced some working prototype. They showed it to business, and they got buy-in. Business said, wow, that's a cool stuff. That's a cool stuff. And they ended up with a big data project, actually, for a year. Like Hadoop, all this fancy stuff. So the thing is that if they would never come with this idea, and if they would never show this prototype, they would never have this big data stuff, right? So business innovation starts first. Find this place where your business is like doing bad stuff, and maybe someone is doing better. Bring some business innovation, and the technical innovation will follow, which is obvious, right? Nice. So there's an alternative to Lasagna architecture called Kind-S architecture. Don't try to Google it, actually. It's not Googleable, because I have invented it. It's like a copyrighted. Kind-S architecture. And it stands for keep it need-driven and simple, sir. Right? Let's be polite, right? Sir. So what does it mean? I believe that we have to become better at understanding what needs really are for our company. So let's back to the basics. What does this needs mean? Because my friend once said that there's architecture in the sake of architecture doesn't really work. Architecture in the sake of architecture doesn't work. It should be purposeful, right? So we should become better at understanding requirements. Do we really need this 5 nines uptime? Or like a 2 nines uptime is actually enough? Because it can make a huge difference, like maybe millions of euros per year, right? You have to think about it. Do you really need 100% data consistency? Or do you really need like a highly concurrent stuff to be based on type safe, stack, echo, something? Okay, if you need, maybe it's just part of your application that should be reactive. Maybe you should produce a service and leave the rest of your application intact. Why not, right? Risks. Have you ever heard that Clojure developers, they drive fast motorbikes? You heard that, right? And do you know that Cassandra developers, they usually win lottery tickets? Yeah, and that's how it happens. Usually we don't even take this into consideration often enough. What about constraints? Does our company have the same constraints as Google? The same people, same money, same innovation budget, whatever, development capacity. We want to have domain-driven design. It's modern, right? However, do we really have a domain expert in-house? Or are you going to Google domain terms in Wikipedia, something? It's not going to work, right? So different constraints. Do we have tight deadlines, whatever? So I think that most holy wars actually in the companies, in the team happen because we really don't understand the current situation, where we are, right? And if someone says you, but Instagram did that. Have you heard about this Instagram story? Very, very motivating, when 2 developers produced Instagram, and they were business guys, ops guys, developers, testers, investors, so same 2 person. But you are not Instagram guys, and I'm not too, because maybe you have a family, I don't know, you have different constraints, different reasons for doing that. Maybe you like beer at the evenings as well, right? So maybe they don't drink beer, so that's why they came up with Instagram and actually build it. So that's more exception than a rule, right? And there is something that can help us, like a Maslow's hierarchy of needs in software development. Basically, maybe right now you are not profitable in your business. So why the heck you care about technical innovation? Just stop it. Make business profitable first, and then maybe you will end up with something more technical, right? There should be right time for doing things, right? Or alternative view from a lean enterprise book. Basically, let's say if you are at explore phase, you're like working in a startup, let's say, and you don't really know whether a customer is willing to pay you money for a particular thing or a particular product. Do you really want to do test-driven development or some like a very like a cool, like a important engineering practice at this stage? Do you really want to do that? Because you are not sure. It's a long-term investment, right? But you are not sure whether it's worth investing at this stage. You don't know. But once you cross the chasm and go like toward this exploit phase where your business idea is validated, you can apply absolutely different practices. Understand where you are now. Where you are now. Is it the right time for doing particular things? Simplicity. I'm not going to talk about simplicity a lot. It's pretty obvious because Chad Fowler, like the author of Wunderlist, blabs about simplicity a lot, how to make small teams, small iterations, small software, small ideas, small experiments. So there's a lot of things already said. Kathy Sierra says a lot about simplicity. Actually, she tries to connect simplicity with the way how our brain works. There's a scientific evidence that say that we have to keep things simple. But what I want to say you, just really, Mr. Obvious, pick the tool you know well and ship the simple possible solution. That's it. Simplest possible tool. Why? Because usually, when you are fed up of enterprise environment, and let's say you join a startup, you're bored of this Java, EE, I don't know, .NET stuff, you join startup, and what do you want to do? You want to build a startup, and you want to play with fancy tech. Two things at once, right? That's how it is, because you didn't have a chance to play with it before. But you will have a lot of things to learn besides this technical stuff. You concentrate on something you know well, right? Because the thing is that you can always add complexity. You can always add complexity on top of something simple, right? But once you have complexity in place, reducing complexity takes much more time and effort. Complexity can be always added, but reducing complexity requires much more effort than just adding it. Optimize for change. This is important because there's no such a thing as, basically, we strive to make something flexible architecture, right? But flexibility comes with a cost. Why we should build something flexible? Because you don't know anything about the future. You can try predicting, but you don't really know, right? So, okay, you don't know anything about the future, and maybe you can try doing something reusable as well. But have you heard about use and reuse paradox? Because obviously, things that are easy to reuse are hard to use. There's a paradox. Right? That's an interesting one. So basically, what should we do? What should we do? You're now somewhere here in the time. So what should you do? You have to make sure that you choose simple possible solution that you know and optimize for change. Make sure that it's easy to change things. So you have to concentrate on simplicity, which gives ability to swap things in future, to roll back your decisions, right? Make things simple. It's enabler for like a changing and replacing things. And usually, when you have a choice, like an architectural choice, let's say, they're either A or B. What do you normally do? You either choose A or B. But this is actually an indicator that maybe, since you don't know which option to choose, it's an indicator that you have to abstract out, right? So to reduce the cost of changing your decision later, right? That's what evolutionary architecture is actually about. Nano-service architecture. Woohoo! And I would like to call it microservice architecture, but for me, it would mean a suicide, right? Because you can't call microservice architecture anti-pattern nowadays, right? It's dangerous for your career. It's dangerous. But that's when service-oriented architecture goes wild. That's when you go toward this microservice architecture, because it's insane, you know? It's just insane. How can we say that a service must be of a particular size? How can it be? Do you know how big microservice should be? Who knows? Raise your hand. No one, right? Me too, I don't know. However, if you Google it, I like it. Microservice should not be bigger than like 300 lines of code. That was the rule somewhere, okay? Someone says it's bullshit. There's a better idea. You should be able to rewrite microservice in 2 weeks. Wow, so concrete. So concrete. Have you heard that? Or the best. Microservice team, you should be able to feed microservice team with 2 pizzas. Have you ever heard that? You see? Very concrete. Very concrete. So I believe that thinking in this size actually leads us to wrong conclusions and wrong assumptions. That said, microservice architecture can give us some benefits, but mostly, if we apply this size reasoning, we make things only worse. And here's a Sufi teaching story. You think that because you understand 1, that you must therefore understand 2, because 1 and 1 make 2. But you forget that you must also understand and. And it's all about microservices, because when you end up with a microservice architecture, truly microservice architecture, you have to understand every service interaction, and you have to care about data locality, partial failures, all the things. It makes things complicated, and a lot of things are besides that. So I believe that by blindly splitting system into microservices, and most teams actually doing that, they just blindly split these things, like a monolithic apps, into microservices, you get only negative consequences with questionable benefits. What if we roll back and just forget about this micro? What if we just call it service-oriented architecture, right? Because size doesn't really matter. Sometimes, right? It's about software, right? We're talking about software now. So it's much more, it's less confusing, right? There's no confusion, micro, it's a service. There should be services, but no one says that there should be micro, right? Good. The thing is that we have to forget about size because there are well-known driving factors for decomposition. Well-known, and they're not pretty, they're kind of subjective, but if you're smart enough, you'll figure out where to go this way. So, team boundaries. We have 2 different teams. Let's say there's a wall between them. If you remember the story about continuous delivery, there's a wall between them. We want to give autonomy. Why not to split application into 2, right? Frequency of change. I have 2 services. Like I have 2 different functionalities, and they change at a different frequency. But I have to deploy these things together. Why don't we split these things into 2 parts? Different responsibilities of the system, different cross-functional requirements. Some parts of the systems are maybe more highly loaded than the rest, right? Different technical stack. I want to play with a closure. I want to play with a Groovy. Or I want to run a prototype and then throw it out, and maybe once I validated ID, I rewrite the things back by using an older approach. So there are driving factors, and we should know about them. Forget about size, because actually staying big is kind of okay. Staying big is okay. Just take this as a takeaway. Staying big is okay. There are companies working on big services, and they do continuous delivery, they move fast, and they're happy, right? So, but don't do this blindly. Decompose wisely, because benefits of service-oriented architecture are not in size at all. It's not the benefit, right? Mostly. Structureless architecture. So structureless architecture is architecture which, basically, it happens when we don't have a structure at all in our software system, kind of, it's totally ad hoc, or we have a structure that we can't benefit from. And here's the example. Looks familiar, right? That's how we tend to structure software. Configuration, controller, DAO, domain, service. That's how we structure business software, right? Normally. That's how we do. That's how we do, right? Who does that? Be honest, be honest. I do it as well when I joined the team existing, and they forced me to do that. So, and that's a problem, because have you heard about this idea of a screaming architecture? Screaming architecture, yeah? Exactly. So screaming architecture from Uncle Bob says that your architecture should scream about its functionality. It should say what it actually does. So what this particular structure screams about. It says that our application is doing controller, DAO, domain, and exceptions, right? That our application is doing exceptions. What the fuck? Yes, sometimes it does exceptions, but is it really a functionality or something? It doesn't make sense. So the thing is, let's burn this approach in fire, because it does not really reveal high-level components. It doesn't say what system is doing at all, right? At all. It does not reduce discovery cost, which is important. Basically, discovery cost means that how much time do you spend on understanding what causes a particular problem, so where to find the root cause of a problem. Because how often a particular layer is a source of failure? Oh, we have a problem with exceptions, right? No, usually have a problem in some particular place of functionality, right? Or comprehensibility. I want to study a particular piece of functionality at a time without caring about the rest of the application. Right now, exceptions are here, domain is there, DAO is there, so you can collect yourself, right? Just collect it back somehow in your mind, right? Doesn't really work well, and it does not enable Poka-Yoka, which is a guideline for a lean software development, which says that once you're in rush, you do crappy things. I can't really enforce constraints between functional units, which are important. I can't really tell that some part of functionality shouldn't really talk to the rest of the app. So what if we do it differently? Boom. Whoa, very unfamiliar or inconvenient, right? Even uncomfortable. Wow, what if we just do it differently? What if we package our software based on a functional cohesion? That's how it is. So, right now, first of all, it says at least something what our application is doing. Group stuff, discover, meetups, there's a user stuff, it has a registration, and there's usually even validation stuff. So it says what our application is doing. It reduces discovery cost, because once I have a problem with registration, I go to registration and just look what happens there. While I'm studying registration, I don't care about the rest. It actually enables Poka-Yoka. Basically, I can say that user stuff should be independent of a group stuff and not vice versa, and you will understand why later. So I can enforce it somehow automatically, which is a good thing. So what if I will tell you that it's worth applying service-oriented mindset that we have now already on a structure level? What if you can think in services without doing distributed software, right? What if we organize our software around services and make sure that they are decoupled? Yeah, something new, probably. How many Java people we have here? I will skip the slide, okay. Nice, I will skip it because it's okay, it doesn't make sense now. So, and the question comes, where is layering? Where is layering? Let's talk about Lasagna architecture then, right? Lasagna architecture. Lasagna architecture happens when you have too many layers, right? It's also called onion architecture, because when you open so many layers of onion, you start to cry. Right? It's onion architecture. And here's the list of official benefits of layering. I took these benefits from official books. That's not my invention. However, it's funny, because most of these things doesn't make sense anymore nowadays. So what if your takeaway would be today that layering, most of the time, in your application doesn't make sense? You go to your team next day and say, layering doesn't make sense. Wow, 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 wow. But that's a good focal point for conversation, right? Because usually it really doesn't make sense. For some reasons, we're still doing that in our business application. I don't know, why Spring Framework, let's say, doesn't really have layering? Why some other libraries or software doesn't really have layering? They do it differently for some reasons. Why do we still do layering? It's a good question, right? And what if I tell you that if you apply this service-oriented mindset to your structure, you can let your services decide which layering is the most convenient for these particular services. So this fuck this unified layering model within our monolith, right? So let your services decide, because maybe some services don't really need layering at all. Let's say if you do some services can benefit from CQRS, doesn't make sense to go for a service layer when you do querying. Maybe it doesn't really, right? So different services have different functional requirements, have different structure, have a different layering. But usually we go towards layering when there's too much stuff in our packages or something, so we tend to split to simplify our life. However, there are different ways. So what if we split our functionality into smaller units when packages start to grow? Don't do layering, extract new functional units out of your packaging, which is a good thing, right? Or if you find out there are some cross-functional concerns bubble up, just extract them out of your system and keep in the separate models at all. So the thing is that keep services mind-sized. So keep your services mind-sized small, so there is no need for internal layering. And make sure that you rip out some reusable stuff out of your system at all, so to simplify things. So we mentioned lasagna-oriented architecture. We mentioned ravioli-oriented architecture, microservers, right? That's how software evolves. And the question is, what's going to be next, right? I don't know, for pizza-oriented architecture or something. So that's funny, right? So architecture evolves as a food. Sorry? Italian food, exactly Italian. So, okay, funny. And by the way, one more thing. If you apply this service-oriented mindset to your structure, what's important, I think so, that it will, if you care about this stuff, it will make so eventually when you will decide to do service-oriented architecture through service-oriented architecture, it will make your life much more easier when we'll try to extract things, because your right structure is already there, and you will be able to figure out what should you rip out together with your service. It's already there, so prepare for that. That's it about structure. Let's talk about documentation. Yeah, our favorite. Undocumented architecture. Undocumented architecture. And I know that you hate documentation, right? Who loves documentation? Oh yeah, that's what we do. So we hate documentation, and I used to hate documentation too, before I found out that there's a personal benefit for me in documenting things. Basically, when I document stuff, it makes me a better thinker, because it teaches me how to organize my ideas and make them structured. So you always have to find some of the personal benefits. Believe me, once you start documenting things, it will make your life better in some other aspects. But it's not about that. It's about personal stuff. Have you heard about this idea? Prefer comprehensive software. Prefer working software over comprehensive documentation. That's what Agile Manifesto says, right? Prefer working software over comprehensive documentation. But there's one word that's very important. Prefer. Prefer. Is prefer the same as replace? No. But what we do? We replace. No need for docs, right? So the thing is that it says that at some places when you can replace your documentation with a software, working software, it's good, go for it. But sometimes you can't. You just can't, okay? It also says about comprehensive documentation. It's more important than comprehensive documentation, or maybe bad documentation. So it doesn't say that it doesn't compare working software and good documentation. It says about comprehensive documentation, right? It's tiny details. You can say architecture is code. Architecture is code. Simon Brown says that architecture is code. Yes, it's code, but the level of abstraction is too low, because you can't really express some ideas. Like a code says you what is there and how it's made, but does it say why? No. Okay? And there's one more idea. People say that They remember everything. I remember everything. And that's what happened. You go out after a beer party. You see, you had this whiskey party after the conference. Just look at it. La 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 la. After a conference, and you may be lucky enough. But maybe maybe you can't. You will not be that lucky. So there's a buzz factor, right? Be careful. So code has really hard times telling you about few major things, like backup, disaster recovery, redundancy, failover, ETL, SLA. Try expressing it in Java. You'd like to, but you can't, right? It's a problem. Significant decisions and agreement, like rejected frameworks. Let's say, usually when you onboard new people, they come to you and ask the same question over and over again. Why don't you use MongoDB? And you want to point them to this documentation, but you have nothing to point to. You have to explain over and over again the same things, right? Surroundings, dependencies, service consumer, onboarding, how to onboard people, where to find code, how to build stuff, how quality control process looks like, deployment, blah, 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 bird's eye technical view, all this stuff. Today, I try to express disaster recovery in the code. That's how it usually looks in the companies. Just look at this. That's how it is usually, right? And what's important is you keep this method private, right? Because you don't want any, management to know about it. Like a success likelihood. So you can try, but it's not going to work anyway. So the thing is that, so it's a skill. You can, documentation, it's about like polishing your skills, and you can become better at it. So have you heard about Eric's, do you know this framework called Eric's Java? Eric's Java. It's from Java world. Basically, the thing is that Eric's Java is one of the most well-documented frameworks, open source frameworks in the world. So how they came up with such a good documentation? They actually hired a guy who is great at documenting things. He's like a documenter, writer, technical writer, and he served as a coach for the rest of the organization. So he actually forced everyone else to write docs, and he showed the way. Documentation is awesome. Pictures, examples, all this stuff. It's a pleasure to use, right? So you can do it the same. I had one guy in the team who was so good at documentation that he didn't even wanted to talk to people. That's another extreme, right? So document the important things and concentrate on the face-to-face documentation, right? Communication. And the thing is that what's funny about documentation that obviously that shitty out-of-date documentation is worse than you don't have documentation at all, right? Because it even confuses people. So if you don't want to become better at writing docs, just don't do it. But if you want so, it will make life much more easier for you. And I have a story. So I used to be like a software development manager in a small organization. And organization started to grow. It started to grow, and management decided to bring outsourcing guys to join a team to help us with the work. Like a bunch of outsourcers, a huge team, because we were too slow in-house. We're too slow for them. So they hired a bunch of outsourcing, and they came to us and said, outsources, how your systems work? And that was a good question, because our system was very, very, very complicated. Very complicated. Lots of services, and we were doing everything in-house. And it took us as a team like a week or two to onboard this guy to explain some things. However, they were asking same questions over and over again. When we onboarded them, we said, whew, they left. Yes, yes, yes. After a few weeks, internal audit came. So you guys in this jacket say, how your system work, guys? Once again. So I had to explain once again how to do things. It took me 1 more week, approximately, a lot of discussion. And then, actually, a company hired, there was a process of acquisition by 1 more company, and they brought more in-house developers. And we had to explain it once again. So That time, I want to commit suicide. I want to pick a gun. But the problem is that, first of all, I didn't have a gun, right? And I just love myself too much. So that's only what saved me, really. That's the only thing that saved me. So at that time, I wanted to have something to point them to. A few words about architecture, like documents. Have you heard about C4? C4 is good. So basically, UML sucks, right? Everyone agrees. So no one should learn UML. You have to unlearn UML. Good. Who invested time in learning UML? Great job, guys. However, there is a better way. So context, containers, components, classes. I encourage you to go through it because it can make your documents fancy. You see, like a Twitter, some icons. It should be fancy. Documentation could be fancy. And what's important, you can actually generate your architectural diagrams out of your code if you apply the service-oriented mindset to your structure. There's even a tool for that. Nice. You can learn it later. Optimistic architecture, right? Things will never fail. Everything will go well. Nothing will go wrong, yeah? So the thing is that we should understand that we live in a constrained environment, right? CPU is limited, network, memory, everything is limited. That sucks. Environments are unreliable. Things fail. All the time, things fail. The question comes when they will fail, not like whether they will. And things fail unpredictably, right? Things never fail glamorously. Never. Did you ever have a glamorous failure that you could expect and predict? Usually no. Things just fail somewhere and you can't really expect it. So that's a problem. And the thing is that I believe that nowadays frameworks or tools that we use, they don't really force us to think about fault tolerance. They don't force us because let's say you pick something like a Spring Boot or I don't know, some like a Python microserver framework, just bam, 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 add new like a service, bam, 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 and it works. It just works. It doesn't force you to think about fault tolerance. That's a problem of our nowadays frameworks. They're optimized for business development, right? Make things faster, produce more functionality as soon as you can, right? That's what we try to accelerate. So they force you to be optimistic and like a neglect failure, right? But all we know that fault tolerance is the lesson best learned offline. And that's how it is, right? Just raise your hand, my friends, if you know what connection and thread pools that your application has. Raise your hand, like connection and thread pools. Someone? Okay. Just keep your hands raised. Don't be shy. Okay. Okay, just keep your hands. Their approximate size. Approximate size. 5 people out of this room. That's funny. Utilization during peak load. There's some like a Opera effect or Black Friday. Okay, nice. Do you know what will happen with your app when pools will approach size limit? Out of memory, right? That's what usually people answer. Out of memory, right? Nice. Can you handle it? Can you handle it somehow, automatically maybe? Can you handle it? So when there will be a Black Friday, things will go down, right? Okay. And how to timely react on it. That's funny. Only a few hands, right? And that's our reality, because in some teams, only a few senior or ops people know how their application work internally and how to handle the load, which often leads to something like this. Boom. And that's the worst possible time that you can have. That's how it happens usually. You're I don't know, ops guy or a manager or a developer, and you have a call. You pick up the phone, and there's a manager or your boss. Hello. And there's a silence, and you have to answer. You have to say something, and you don't really know what to say. And you just get, by keeping silence, you understand that something is going wrong. You will have a discussion tomorrow, right? You don't want to be there. I was there. It's a very shitty situation, right? That's how we learn when we start to lose money. So there are more things to care about. And the funny thing is that it's finite number of things that we have to care about. It's finite, actually. There's not that much things that can go wrong. There are a lot, but at least we can start with something. And I'm not going to talk about them in details now because, again, we're running out of time. That's how it is at my presentation. We're running out of time because so many things to say. However, we can handle them, and there's the patterns, right? Huge list of patterns. You can learn about them. Did you read this one? Release it. Oh my God! After this conference, you don't go to a lunch or somewhere, you go to a bookstore. Right? So that's the right place to go because this is awesome book. It teaches how to embrace failure. Just say, we love failure, and it says what to do in order to love failure. Because if you don't care about resilience and fault tolerance, you will stop loving failure after this call. With a silence, right? There's one more, but this is better, so skip. Alchemy Architecture. Look at this guy, he's a magician. There was a chair. There was a chair, and no one can understand how he ended up sofa. Look at it. That's what happened in software teams. Well, Alchemy Architecture is about things that we know, we have architecture or something, but no one understands why. You say, why? And well, don't know. What I usually do, when I join a new team, I grab someone from the team and ask 4 questions. Like I grab someone for a coffee and just, hey, can you explain me why these 2 components talk via messaging, not directly, like point to point? And there are 4 possible answers. I don't know. I don't know. Okay, I'm fine with it, you don't know, okay? Second answer, someone knows. I have to ask someone. I will ask someone. I have to figure it out. That's the third one. And usually it means that either I have to ask someone or I will go to docs, which is out of date usually, so he'll get back to me and give me wrong information. Or I know. But chances are that he's wrong. And then what I do, I grab another guy for a coffee and ask the same questions. And my personal statistics shows that answers are absolutely different. People don't really know. So within a team, there's no coherent understanding why something is done in a particular way. It's just never happened most of the time. And the thing is that architecture must evolve controllably, right? Controllably, not ad hoc. However, how can you evolve something that you don't understand? Huh? In Russian, it's called galimatsia, right? Galimatsia. So the worst thing that can happen that when people start to pull architecture in different directions because they think that they know. So how we can end up with like a common understanding in the team? I have a few practices. First of all, make sure that architecture is visible for everyone. That's an easy one. Create a get-together, go to the whiteboard and sketch. Just understand when you are. Just draw a picture of your architecture. Learn this C4. Try to apply C4 model. Sketch your architecture and pin it somewhere so it's visible. It will serve as a focal point for communication for everyone. We're doing things wrong. That our architecture sucks, something like that. Once you have some discussion, go to this place and like brainstorm, change things. That's a good start. Get together, draw things. Next step, you have to understand where to go. Do the same with your ideal architecture, where you want to be. Sketch it, pin next to it. Where you are, where you want to be. Usually, if you go from a monolithic architecture to microservers, it looks like this. Yeah? It looks like this. It looks like this. So, but that's a good start, right? One more thing. Make sure that everyone is involved in decision-making, right? Okay, so once you have architecture, significant decision, come together and just decide, right? Good. So, and maintain the doc, maintain the history of decisions taken. That's important. Don't just decide because someone may not attend your discussion, right? So maintain the docs, why and all this stuff. Because first of all, it will force you to think constructively, right? It will force you to express ideas somehow. Usually it looks like this. So you have a wiki stuff, and once you meet together and talk about architecture, you have something like this, like Code stuff. Wrap all SQL statements with SQL math. Maybe it's a good blah, blah, blah. Test all changes, even very technical. Notify QA. Maintain and fill domain language with new terms. Blah, blah, blah. That's it. Good. Then you integrate it with a chat system, something like a Slack or HipChat. And you can notice that Slack is a slightly bigger than HipChat because it's just better. Right? So HipChat is slightly smaller than Slack. So, and what happens next? So someone who did not attend meeting will get notification, and what happens next? Discussion in a flame on a confluence, something like this. So I like this, and that's the right time when to solve problems, right? So you come up with agreement, and it's gonna be much more better. Last thing, I call it architectural pitch. Once we had a product team with a product manager, and people were not very motivated in the team because they didn't really understand why we have to do something. So we came up with the idea of architectural pitch. Well, sorry, product pitch. Let's say before doing something, product manager gathered the team and he made a pitch. We have to do it this way because it will increase the revenues and make our customers happy, blah, 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 blah. And everyone, yeah, let's go, let's do that. So that was like a product pitch. Good idea, actually, how to make sure that everyone is on the same bus. And I was thinking about it. Maybe we can apply these practices in the technical teams. Why don't we try, when we change our software or have a architectural change, we get together and as me, let's say I'm going to implement something, why not to pitch the way how I'm going to do things? I'm going to do this way, this, I'll put something, and people say, what the fuck? That's absolutely a shitty idea. And that's the right time, once again, you come up with the common denominator and agree. Because otherwise, it might be late. So you can try doing this architectural pitch, right? And that's all I have for you today. Thank you.